Okay, hello, BC Part 1, and happy Halloween. Um, so, this is homework for tonight, and in this screencast, you are going to be introduced to a whole new family of expressions and functions called rational expressions and functions. Actually, I shouldn't say introduced to. We've actually worked with these in a very superficial way. But I just want to go into them in more detail now. Okay, like everything we do, we just cycle back, cycle back, cycle back. So the first thing I want you to be aware of is the difference between rational expressions and polynomial expressions. We've worked quite a bit with polynomial expressions. I put a couple up here, 3 up here. Some of the expressions have been factored, okay? Some have not. But polynomial expressions are defined by having no domain restrictions. In other words, no restrictions on the variable value, right? They're defined by integral degreed terms. If we were graphing polynomial functions, these are not polynomial functions, but when we graphed polynomial functions, we know that the domain's all real numbers, they're smooth and continuous, et cetera, okay? So the first thing I want to talk about is defining what rational expressions are. Rational expressions are expressions that are quotients of polynomials. So here are a few examples of rational expressions. 6x plus 12 over 2x cubed minus 6x squared, right? Rational expressions are expressions that are polynomial over a polynomial. Here's probably the simplest of rational expressions, 1 divided by x. Sometimes rational expressions will be a polynomial that's factored in the numerator and a polynomial that's not factored in the denominator, or vice versa. But before we go into the work of rational expressions, we should really know what it makes an expression rational. And a rational expression is an expression that describes a quotient of polynomials. Okay, it is a polynomial divided by a polynomial, right? That's what a rational expression is. And when you have expressions, boys and girls, you can't solve an expression, right? Equations are solved. Expressions can be simplified, they can be factored, they can be manipulated, but let's first talk about simplifying rational expressions, all right? So if you have a rational expression like this, let's just be sure that we review some basics of simplifying. Simplify the rational expression, and let's put a few up here. Okay, let's start with this one. Number 1, x squared minus 16 all over x squared minus 6x plus 8. Okay, first of all, if this is a rational expression you're asked to simplify, remember that you cannot cancel out terms, right? I know your hand wants to cross off x squared and x squared. X squared, though, is a term. Terms are added or subtracted, okay? In a quotient, you cannot cancel terms. You can, however, cancel factors. So what I'm going to do here with this rational expression is see if I can factor the numerator and factor the denominator. And if I look at the numerator, I get x minus 4 times x plus 4. All divided by x minus 2 times x minus 4, right? And now that I've factored the numerator and the denominator of the rational expression, I can say, well, any common factors can be canceled. And at the end of the day, my expression is x plus 4 all over x minus 2 is my simplified rational expression, okay? Now, there's a habit that I want you to pick up that your text does not reinforce, but I want you to pick this up. When you have a rational expression, okay, because a rational expression is something divided by something, because division by 0 is undefined, right? So because division by 0 is undefined, right? The denominator can never equal 0. Okay, what that means is, in this case, we're saying that x squared minus 6x plus 8 can never equal 0. And if you just look up here for a second at the denominator when it was factored, you will see that if x were to ever equal 4 or 2, that would make the denominator equal to 0. So when we simplify an expression, I want you to always say to the reader that you just simplified the expression, but you know for this rational expression, x cannot be 2 or 4. And I know some of you are asking, well, even though the x minus 4 canceled out, do I still have to account for that in the domain restriction? And the answer for right now for this screencast is absolutely yes. And I will talk about why tomorrow during our long period. So when you have a problem like this and you simplify an expression, I want you to always give the simplified expression and then say x cannot equal 2 or 4. Okay? And right away, you see a difference between simplifying rational expressions and simplifying polynomial expressions. Let's scroll up for a second. If you were asked to simplify this polynomial expression, right? Let's say you're told to simplify this polynomial expression, you would simplify by combining like terms, 3x squared minus 6x minus 11. And you'll notice you never had to say any restrictions on x. You never had to state the values that x can be. And the question I have for you is, why is that? The reason why is because it is understood well that for a polynomial expression and polynomial functions, there is no value that x cannot be because the domain is all real numbers. Okay? Let's try another one. Let's simplify this rational expression. Are you ready? Let's try. All right, I'll simplify this one. Let's get a more juicy one up here. How about t to the 4th? I'm just going to pull this one off of your homework. Why not? Oh dear, sorry, I just wrote the wrong one down. Pardon me, sorry. I think it's Nancy who gets annoyed with me when I write something and I erase it. I'm sorry, Nancy. If you've ever seen Nancy's work though, Nancy has the neatest, most succinct, minimalist handwriting. It's so beautiful. Okay, let's simplify this rational expression right here. Now, generally speaking, boys and girls, when you have a rational expression with more than one variable, I will not ask you to kind of state the domain restriction. It just gets a little clumsy, all right, because you start having things like x cannot equal y. It's just a little bit clumsy. So just note to self that if you have a rational expression and you're simplifying it and it's more than one variable, you don't have to go the route of saying what the variables cannot be, okay? So why don't you go ahead and see if you can factor the numerator and the denominator and then replay me, okay? And I'll give you a hint. Maybe try factoring by grouping. Let's see if it works. Okay, so this was a juicy one, right? So I gave you a hint of factoring by grouping, and notice how I grouped, okay? Note my red parentheses. Notice here that if I'm grouping and there's a negative sign, all right, notice how I have to make sure the parentheses does not interfere with the integrity of the expression. So I just made this negative 4x a plus negative 4x plus 4y. And then I grouped the denominator with the first 2 and the second 2. Now, what's interesting is look at this. Look how x squared minus y squared factors. Okay, x squared minus y squared factors as x minus y times x plus y, x minus y times x plus y. And then what I did is, if you look at the numerator here, right, I noticed that if I factored negative 4 out, right, I'm left with an x plus y. And in the denominator, if I factor positive 4 out of the second grouping, I'm left with x minus y. All right. And now what you have to do, and I know we've done this before, but I'd rather be thorough. From this to this step, you want to think of this as the numerator has one term minus a second term. and those two terms share a factor of x plus y. So look what happens. I'm going to factor out the x plus y, right, or undistribute, right, undistribute, factoring out a GCF. And what's left, if I factor x plus y out of this first term, what's left is x minus y. If I factor x plus y out of the second term, what's left here is minus 4. Okay? Similarly, in the denominator, I have one term plus a second term. Common factor here is x minus y, right? Here is x minus y, undistributed, factored out. And then what's left is, when you factor out x minus y out of term 1 and term 2, x plus y plus 4. Now, the casual observer, and you all are not casual observers, will look at this and say, oh no, this is so interesting. None of these factors are the same. None of these factors can be canceled, right? And I just urge you to take a little bit of a closer look for a second, all right? And you will see that something, whoops, hold on, I made a mistake, everyone. Hang on, let me look. Oh, whoops, over here, boys and girls, look. See how when I factored -4 out, right, of this, factoring -4 out, that makes this a minus. Sorry about that. Let me go over here. Make it a minus sign. It should be x minus y. X minus y. Yes, honey. Hi, how are you?
Did you even know I was here?
I didn't, but now I do. I'm just finishing some work, okay? Hang on a second.
Okay.
-4,
I don't know you were
x
here.
minus y.
I don't have any homework.
You don't?
Halloween.
Wow. X plus y minus 4. Okay, there you go. Sorry, boys and girls. I had lost a negative. Sorry. Okay. Now, when you look at this, you'll see, oh, constant factor. At the end of the day, my simplified rational expression is x plus y minus 4 over x plus y plus 4. Okay? So that was I just kind of jumped. I just went from 0 to 60, right? All right. And like I said, again, expressions where there is more than one variable, you do not have to write me the domain restrictions, okay? All right, why don't I give you a couple more to try. Would you please go ahead and simplify if you would. Let's simplify the following. Number 3. Let's make this, okay, x to the 4th minus c to the 4th all over all over x plus c squared times x squared plus c squared. Okay, we're going to simplify that rational expression. Again, that does not require you to state the domain restriction, and then simplify this rational expression. Oh dear. And then I will say to you, make sure, please, you do not scare small children tonight. 6x squared minus 5x minus 6. All right, go ahead and simplify these. So for number 4, I would want domain restrictions, and for number 3, I do not. Go ahead and simplify those, and then replay me for the answers. All right, here's number 3. Okay, follow me over here. So number 3, the numerator is a difference of squares, right? It's in quadratic form, but a difference of squares. And you'll notice that x squared minus c squared factors further to x minus c times x plus c. X squared plus c squared does not factor any further. All right. You'll notice I wrote x plus c, the quantity squared, as x plus c times x plus c, just to make it very clear to you. X squared plus c squared here, all right, that doesn't factor any further. You'll notice already that these two cancel over here, and then also these two cancel. This is my final simplified expression. Number 4, the casual observer would factor right here. And they say, oh no, there are no common factors to factor out. And you are correct, there are none. However, do you see that if this, if the sign of the 2x were negative, so in other words, if this were negative 2x plus 3, then I would have a common factor here and here, right? But guess what? I can make this factor, negative 2x plus 3, by merely factoring or undistributing, okay, factoring a negative 1 out. So my denominator is going to become this, all right? 3x plus 2, I'm going to factor out negative 1, and I will have then negative 2x plus 3. And if I go above, I recognize that negative 2x plus 3 and 3 minus 2x are the same, and then those could indeed cancel. Unfortunately, the same trick here would not work, right? I mean, 3 plus 2x and 3x plus 2 don't just differ by a factor of negative 1, all right? So at the end of the day, my final simplified expression is 3 plus 2x all over negative the quantity 3x plus 2. All right, and I said that I want you to have a domain restriction. Say what you know x cannot be. X cannot be 3/2, because if x equaled 3/2, this factor is 0. X can also not equal negative 2/3. All right, let me come back with you for the homework for tonight. I will keep it relatively light, and I look forward to seeing you tomorrow. Okay, and here's your homework. In the Algebra 2 book, this page right here, I gave you a hint. For some of these, you may want to look up in your notes the difference and sum of cubes factoring patterns, okay? All right, happy Halloween. Goodbye.